Hi Calc. This is the next optimization problem we're going to try. I know it's sort of long, so I'll read it as I do it. You basically have a rectangular piece of paper. And on that rectangular piece of paper, you would like to write some words, but have a margin around those words. So the margin at the bottom and the top of the page are 1.5 inches. Okay, so just so you can sort of have a visual here, what you have is you want to write some words on the page, and the words are going to take up a certain amount of area on the page. And the requirements specify that the top and the bottom has to have a 1.5 inch margin, and the left and the right have to have a 1 inch margin. Okay, that's the idea. What's the dimensions of the big page? What are the dimensions of the big page so that this can happen? If the page is to contain 24 square inches of print. Okay, so basically the idea is that we want the smallest, the threshold of the smallest piece of paper that can hold 24 inches of print with these kind of margins. Now, if you let me write on a wall, I can certainly fit this amount of words on it. But the moment you start shrinking down the size of what I'm allowed to write on, there's a certain threshold where you've made it too small and I can't fit the stuff on there anymore. So we're looking for the threshold of where it's the absolute smallest piece of poster or whatever that I can write these particular constraints on, with these particular constraints. So I can write the words on with these particular constraints. All right, so the primary, the goal is to make this piece of paper the smallest we can make it, the big one, like the poster board. So let's get the dimensions. So the easiest way I think to do this one is I would call the words, I would call this side X and this side Y. There's more than one way to do it, but I sort of feel like this is the easiest. So this is X by Y. Now, the bigger part then, this part, X, you're adding here an inch on each side of X. You're adding an inch here and an inch here. So this whole thing here has to be X plus 2. This one, this side, you're adding a 1.5 inches here and here. So this whole side here is going to have to be Y plus 3, because you're making it an 1.5 inches bigger here and an 1.5 inches bigger here. So altogether, that's going to be the Y value plus 3. So the primary goal is to take the big piece, the area of the big piece, the big one, and make this a minimum. How small can we make this poster board? What's the threshold where if I make it any smaller, I can't fit the words on? And the secondary condition is that the words have to be, the area of this has to be 24 square inches. The print part has to contain 24 square inches of print. So the print part, the area of the print, has to be 24. Alright, so there's the primary and the secondary. Hopefully you remember from before that you have to plug the secondary into the primary. So I'm just going to isolate, let me go with Y. I'm going to isolate Y. Y is going to be 24 over X, and I'm going to shove it into the primary. So again, the primary is X, sorry, no, that's the secondary. The primary is A equals to X plus 2, Y plus 3, and I had decided we're going to isolate Y, so I said that. Okay, so we're plugging this into here. So now A is going to be X plus 2 times 24 over X plus 3, because I'm plugging this into there. right, so I'm going to have to take the derivative of this, and you want to think about, like, okay, what would be easiest for you to do? Is this the best format? Do you want to take the product rule? Or is there a different format that might be easier for you? So for me, I'm going to FOIL this out so that I don't have to do the product rule. And it just depends how you want to do it, but this is how I'm choosing to simplify it. Let me just make sure I got everybody. This times this is 24, 3, 48 over x, 6. Okay. So here I'm just going to combine like terms. I'm going to combine the 24 and the 6. And I'm going to just like bring up the x. So this will be 48x to the minus 1, right? I'm just bringing up the x. Now here I will take the derivative. So a prime, 30 goes to 0, 3x is 3. Power rule on this, the -1 comes down in front, becomes a -2. I got to keep working on this. So this is the same thing as saying that. I need to get an LCD, so I'm going to put this over 1 and multiply up down by x squared. Okay, I'm going to factor out a 3. Okay, we're looking good. So once you get your derivative of about where you want it, I'm almost there. I just want to factor the numerator. So technically, if I go for the critical numbers, it would be plus or minus 4 and 0. But you got to think this is a word problem and what critical numbers apply and what don't apply. So let's think about that for a minute. Does -4 make any sense for the magnitude of a side of a piece of paper? No, right? It doesn't. Does it make any sense that x would be 0, right? Does it make any sense for your picture that x would be 0? No, because then you'd have no side here. It doesn't make any sense. So really the only applicable critical number here, the only one that works is 4. So you're going to have a minimum at 4. That will be the smallest size poster board that you can get the job done with. So let's go and answer the question. So what is the least amount of paper used, right? That's a minimum. All right, so let's get the dimensions right. So this is inches. All right, so that means that we found that x is 4, but that's the words. That's not that we need this down here. So 4 plus 2 is 6. So this side of the paper is 6. Now we got to go back and get y. Y is equal to 24 divided by x. X we said was 4. So that means y is 6. So inside is 6. But the outside, 6 plus 3, that has to be 9. Okay, so the dimensions of the paper are actually 6 by 9. That is the absolute smallest. If you go any smaller, you can't get the job done. Anything bigger obviously works, but nothing smaller gets the job done. So this is a threshold. I hope you enjoyed that. This was like a cool problem. Okay, gang, I'll catch you again in another one. Bye-bye.